In this presentation, we're going to be discussing REST machining, which is a part of the How to Machine 3D More Efficiently set of videos. So let's take a quick look at what we're going to be discussing in REST machining today. So first of all, we're going to discuss what is REST machining, what is it and how can it benefit us. Then we're going to go ahead and explain the technique on how to REST machine. Then I'm going to go into the software and demonstrate the technique for you. And then we're going to go ahead and take a look at the pros and cons of REST machining, and then we're going to go ahead and summarize what we've covered today. So, REST machining. REST machining is an acronym for remaining stock machining. It is the process where we go ahead and remove the majority of the material first with a larger tool. We then go ahead and compare the machine model versus the model we actually wanted to machine. And then what we do is we create a toolpath which then goes ahead and removes all those unmachined areas with a smaller tool. So why may we want to use REST machining? REST machining allows us to remove material more quickly with the larger tool. This enables us to save time, and this will reduce production costs. There are three methods of REST machining, the first of which is 2D REST machining. The second of which is the manual approach to REST machining, where we go ahead and manually create our own vector boundaries. And the third method of REST machining is a semi-automatic method, which I'm going to demonstrate to you today. So let's quickly break down each of these methods. So first of all, we'll take a quick look at 2D REST machining. So this is where we go ahead and use the large tool first. Then we go ahead and clean up with the smaller tool. Now the software has all the options for this in the toolpath form itself. So as you can see in the pocket that we just demonstrated then, we use this option here which says to use the large area clearance tool. So that will use the larger tool first, and then it will clean up with the smaller end mill afterwards. So this is a form of REST machining. Now we've probably used that already in day-to-day use of the software. Secondly is manual REST machining. So this is where we go ahead and draw vector boundaries around objects that would require a smaller tool, and then we would machine the rest with a larger tool. We also have this option within the software, which is where we can use the fit vectors around the selected objects tool. So that will automatically create a vector for us around the 3D object that we selected from the component tree. And then once we've got our manually created vectors, we then go ahead and create the separate toolpaths using our manual vector boundaries. So we'd have a toolpath with our larger tool, and then we'd have a toolpath with our smaller tool, cleaning up the areas where the larger tool would not have been able to fit. So then there's the semi-automatic method, which is what I'm about to demonstrate to you in the software. But first I'm going to run through the technique with you in this presentation. So first of all, we need to create a toolpath with a larger tool, and then we go into the 4 stages of the semi-automatic method of REST machining, which is where we first of all create a component which is going to be the difference model between what we actually machined and what we wanted to machine. We then go ahead into stage 2, where we use the trace bitmap tool to create us some vectors around the unmachined areas. We have stage 3, which is optional, which is where we can go ahead and edit the vector boundaries that we've created using the trace bitmap tool to create us a faster and more efficient REST machining toolpath. And stage 4 is where we actually go ahead and create that REST machining toolpath. So stage 1. What we do is we create ourselves a toolpath with the larger tool, and then we go ahead and preview that toolpath in the preview toolpath form. Then what we do is we go to toolpaths on the menu bar, and we scroll down to this option, which is the last option in that menu, which is called create component from toolpath preview. Now to create the difference model, we need to press Control at the same time as pressing that option on the menu. And this will then create us the component which is the difference model between the model that we created in the software to what we actually got from the toolpath preview. And you'll see that we'll be left with something that looks like this image on screen now. The new component will be under our component tree and it will be called Toolpath Preview. And as you can see from this new picture here, we're going to get a lot of raised areas. Now this just represents all the areas where the larger tool that we used to create the toolpath it wasn't able to actually machine into the smaller areas, the more intricate details of our 3D model. Then we move on to stage 2, where we use the Trace Bitmap tool. So what we do is we deselect any models that we had ready for toolpathing, and then we select the new component that we just created using stage 1. We then use the 2D grayscale representation of that model, and then we go to use the Trace Bitmap tool. We adjust the settings, and then we use the tool to fit vectors around the raised areas in our difference model. So as you can see in this little picture here, you'll see that the vectors have been fitted around all those raised areas that we had on this model. Then we have stage 3, which is where we go and edit vector boundaries. Now we don't actually have to do this, but it will help us create a more efficient toolpath. So what we do is we remove any small closed vectors, we smooth out any jagged vectors, and this will help us create a much more efficient toolpath because it will have less retracts in that toolpath, which will enable it to run a lot quicker and smoother. Then we have stage 4, which is the final stage in rest machining, which is where we go ahead and create the final toolpath. So it's important that we deselect the difference model that we created and then reselect all the original components for our model. We then also select all the vectors that we've created in this process. We then go ahead and create a toolpath with a smaller tool, and we've got to make sure that we use the selected vectors as the machining limit boundary, as we're going to then only machine in between the vectors. So you'll see that it's only going to go ahead and machine the areas where the larger tool actually couldn't fit. The results. So when we calculate the toolpath and preview the results, we should go from having a model that looked like this to one when we've actually rest machined it to looking like this. So I'll just show you that again. So this is before, and after we've run the rest machine toolpath, we should see that all these areas around the dove and in the wings, they should all clear up, like so. So now I'm going to go into the software and demonstrate this technique for you. So I'm going to open a new copy of Aspire, and I'm going to create a new file, and I'm going to specify my dimensions with a width of 10 inches, with a height of also 10 inches, and with a 3/4 of an inch thickness. We are going to work in with the Z0 off the top of the block, and the XY datum is going to be the lower left hand corner, and the modelling resolution is going to be very high. Once we have these options, simply click OK. And the first thing we're going to do is load in our piece of clip art, which you've seen in the presentation itself, which is going to be the dove and the heart. So simply come to the clip art tab down the bottom, and within the clip art folder you'll see that we have a section called animals. Simply click that, and you'll see that down the bottom here you'll start to see previews of the 3D clip art itself. Now what we need to do is simply scroll down to find the one with the dove and the heart. So just keep scrolling, and you'll find the one that we need to use is called dove heart 1-X. Simply double click that, and that'll then place that in the dead center of the material. I'm just going to go into the modeling tab, as I'm going to now resize that with the transform tools. So with it highlighted still, I'm going to set the selected object size. So I'm going to come into this, and with link XY enabled, I'm simply going to change the height to 9.5 inches and simply click apply, like so. And then I'm going to close to exit this tool. The other thing I'm going to do is I'm just going to quickly just check the height of the actual model. So I'm just going to go with the component selected into the change properties tool, and you can see the shape height is 0.5903. I'm just going to round that up to 0.6 of an inch, hit the spacebar to re-render that, and simply close the component down like so. So before we go ahead and create ourselves our 3D toolpath, Whilst the component is selected, I'm just going to go ahead and create the vector boundary for our profile cutout pass, like so. So you can see that we've got our vector ready for when we go ahead and create that toolpath. So let's go over to the toolpath tab now and create ourselves our toolpath with the larger tool. So before we create any toolpaths, we must always make sure to check our material setup first. I'm just going to have a quick check and can see that is all okay. So I'm going to press OK on that. And now I'm going to go ahead and select the 3D finishing toolpath icon, and then we can go ahead and start specifying our parameters. So first of all, I'm going to go ahead and select my tool. So for the larger tool, I'm going to use the 1/4 inch ball nose on this, and press OK. I'm going to use the machining limit boundary as the model boundary, and I'm going to specify an offset as the radius of the tool, or just over. So I could go to 0.13 for instance, and then just go ahead and press calculate on that. So this is going to calculate my larger finished toolpath, and then we can go ahead and create the difference model from the toolpath preview. So now we've calculated our toolpath, let's simply preview that toolpath in the simulation. And now what we can do is we go to Model on the toolbar and hold Control down and press the Create Component from Toolpath Preview option. And you'll see that down the bottom that briefly had a loading bar, which means it was calculating that toolpath preview. So all we need to do now is go close on the preview toolpath form, go back over to the drawing tab, and you'll see that within the component tree we have that new component which is called the toolpath preview. So to go ahead and do the next stages in this process, which is stage 2 of the process, which is using the trace bitmap tool, we first of all need to turn off our original models. So I'm just going to go ahead and uncheck that box there, and you'll see that we're now left with just our toolpath preview. So we can actually go ahead and actually see what this actually entails. So you can see all the raised edges here, and you can see actually where the tool has left marks because it's too large for the area. You can see that this is where we actually want to try and fit vectors around using the trace bitmap tool, so that then we can create the rest machine toolpath for the smaller tool to go up and tidy those areas. So what we do is we go to the 2D view, and we're going to use the 2D grayscale along with the trace bitmap tool on the drawing tab. So we just select the drawing tab down the bottom, and then we go into the trace bitmap tool. Now we select our image that we want to go ahead and trace around, and then using the black and white option we can use this slider here to scale up and down until we're happy with the areas which are glowing, which is that what we can then fit the vectors around. So if we just move this up and down, you'll see that when I start minimizing the amount of colours in the threshold, you'll see that we're going to start to pick up more glowing areas in the 2D view. So we just do this until we get roughly the areas where we want to fit vectors around. So like now we've gone too far, so we'll just go back one. You see that this is roughly about perfect to what we want to achieve. So what we do now we've got the colours that we want to fit vectors around, we now go to the vector options down the bottom, which is the corner fitment and the noise level. So if we just put the corner fit to tight and the noise filter to 1 and then preview the vectors, if I just zoom in a little, you'll see that they're quite blocky. Now that's because of the corner fitment is tight, so that means they're going to be quite jagged, the vectors. So I can demonstrate how this changes by just taking that slider down to the very loose end of the corner fitment options and just press preview, and you'll see that that's then smoothed out those vectors slightly. And then we've also got the noise filter as well. So as it's at 1 pixel at the minute, any pixels, singular pixels that are picked up with the trace bitmap tool will be ignored, but we can have an option to select up to a maximum of 10 pixels to ignore as well. Now this will come in handy because we don't want small vectors like this, because these aren't going to be able to be machined by a smaller tool, and it's also going to cause more retracts as we discussed in the presentation. So simply move that slider up to the 10 pixels and press preview, and you'll see that the majority of these have now been removed. So once we're happy with the maximum that we can achieve with this tool, we simply click apply and then close. And as you'll see, if I just go ahead into modeling and just turn off the toolpath preview, that will allow us to see these vectors more clearly. As you'll see, we could actually go ahead now and use these vectors to create ourselves a rest machining toolpath. However, ideally we want to be removing any small areas in the vectors that we've got. So we want to be removing areas like this and vectors like this. And if there's any other small vectors around the model, like these ones here, we can just highlight those and press delete to get rid of those, and that'll help us achieve a more efficient toolpath. Now another thing that we can do is we can actually smooth out any vectors that we have as well. So what we can do is simply select all the vectors that we have and go to the drawing tab down the bottom here, and we can use this tool to fit curves to selected vectors. Now you can see at the moment how many nodes and vectors that build up each one of these, and basically to smooth these out we can just change the fitting type to Bezier curves. So if we change that to Bezier curves, specify a small tolerance, so I'm just going to specify 0.02. We do want to keep sharp corners if there are any, and we want to replace existing vectors as well. So once we've done that, we can go ahead and click preview, and you'll see that not only have the vectors become a lot more simpler, but they've also lost a lot of their angular corners as well. So once I'm happy with that, I can just select OK, and you can see that we've got vectors that look like they're going to be a lot easier to work with now as well. Now we could actually go even further as well, because we don't actually need the vectors that run around the outside of our model. We only really need this part of the heart here. So if we look in the 3D view, and I just go and turn back on that model, the areas that we actually needed to concentrate on were, if we just center that, were around just the dove, so where the dove entered the heart, so just this shape here, around the whole of the dove, and obviously all the fine detail within the dove itself as well. And the only part of the heart where we actually really need to get a smaller tool into was this part here, where the two peaks meet in the middle. So we could actually edit these vectors further and actually simplify them down, obviously dependent on if we want to put that amount of time into editing the vectors. So I actually have these vectors already, so what I'm going to do is I'm actually going to import those into the job. So first of all, I'm just going to delete all the vectors that I have on there already. So I'm just going to deselect my cutout vector and just delete the rest, like so. And then I'm going to go and import the vectors that I've already created. So I'm going to go into the drawing tab, and I'm going to go to this option to import vectors from a file. I'm just going to navigate to my toolpath boundaries, and I'm going to import those. And as you can see, these are the vectors that I've got. So as you can see, it just starts from here and it goes into the heart. As you can see, just around the dove, we've kept all the wing detail and the eye detail, and we've also just added in the detail to the rear of the dove as well. And then we've just created a tiny vector here just to accommodate the top of the heart where the two peaks join as well. So these are the most optimized vectors for this particular model. You would obviously need to balance the time between actually creating or going ahead and editing the vectors to such an extent within your own work. So obviously that's where we need to start thinking about balancing how much effort we actually put into 3D machining efficiently, compared to, say, perhaps just running the smaller tool to begin with, or using vectors that aren't so optimized like the ones that we've got here. So now we've got our vectors for our rest machine toolpath, let's just ensure that we've got the correct component in our component tree selected, which we have, and all we need to do now is go ahead and create ourselves that rest machine toolpath. So let's go into the toolpath tab. With the vector selected, let's create another 3D finishing toolpath. Let's select the smaller tool. So I'm just going to use the 1/8 inch ball nose tool. Let's click OK. Let's change the machining limit boundary to our selected vectors. Then we can go ahead and actually change the boundary offset as well. So I'm just going to change that to the radius of the tool so that the tool can roll over the edges of our vectors, just to ensure that we can get any curves that we need to finish off as well. So I'm just going to put that to the radius of the tool, so about 0.7, and then we can go down and calculate that as well. So if we go ahead and just preview that toolpath, we should now see a difference between using the larger tool, which if I just turn off that toolpath you should see now, versus using the 1/8 inch tool on a rest machine toolpath, which then go ahead and clean up all those edges nicely like so. So just so you can see the difference, I'm just going to undo that last state. So there you can see with the larger tool we've got all the tool markings on the wings and around the outside of our dove, and then when we run the finishing toolpath you can see that's then gone ahead and cleaned up the edges around our dove quite nicely. So all that's left to do is create ourselves that profile toolpath. So let's go to 2D view, let's select that outer vector, let's just change the cut depth to 3/4 of an inch. Let's choose our tool, so I'm going to use the 1/8 inch end mill. We're going to machine outside the vectors like so, and let's call this profile cut out, and just calculate that, and let's preview our final design. So if I double click this material here, that will just delete that as it would be waste material, and then we can go ahead and see our final 3D model like so. So now we've gone ahead and demonstrated rest machining in the software, let's go ahead now and take a look at the pros and cons of using rest machining. So the pros of rest machining is the fact that it is a semi-automatic method and it is quick and easy to achieve a rest machining toolpath. It should also save us a lot of time on machining as well, as we can first of all go over with the larger tool and then just clean up the areas where the larger tool wasn't able to actually machine with the smaller tool. So we should be able to save quite a bit of time opposed to actually running the smaller tool over the whole model to begin with. Now the cons of using rest machining is the fact that we can actually create a visible seam at the rest machining toolpath boundary edge. So where the smaller tool meets the larger tool toolpath, we can sometimes get a visible seam between that, but you can just hand finish that, so it's not such a big worry. Another con of rest machining is that it may be more efficient to actually draw our own toolpath boundaries. This could potentially cause less retracts, and it could also give us a cleaner edge or seam between the two toolpaths. So, to summarise rest machining is a good way to machine 3D more efficiently if we can achieve good boundaries. The benefits of rest machining is that it is really easy to set up within the software using the built-in tools, and it is also faster to machine, which means it can only equate to more profits. The software provides all the tools to help machine 3D more efficiently. All we need to do is balance the time between setting up rest machining versus running a smaller tool to begin with.